Now we have a factor remainder theorem question, which is fairly standard as well. We've got two factors that it's divided by and two different remainders. This here is written in a different way to how it sometimes is. It's saying x plus 2, there is no remainder. You could have easily also said x plus 2 is a factor of fx, but it didn't here. Okay, so because this is a factor, we can say that basically change the sign of this, and we can say that f of a half 1 divided by 2, changing the sign, must be equal to minus 5. So that gives us minus 5, that gives us, let's just put that in, 2 to the half cubed in there, plus a to the half squared there, plus b to the half there, take away 6 there, and that must be equal to minus 5. Let's take the minus 6 over and expand some of the other bits. A half cubed is 1 over 8, but times that by 4, times that by 2 and you get a quarter. This is also a quarter here, so it's a quarter A. This is a half B, and as I say, I'll take the minus 6 over and just change that over, so that gives us equals 1. Minus 6 going over to here. Okay, so now let's left out the b there. Okay, now let's times by 4 through, just to get rid of the fraction. We'll get 1 plus a plus 2b equals to 4. So that gives us a plus 2b equals to 3. So this is one of these ones where we're just going to set up a simultaneous equation. Okay, let's write out the other one. We know that f minus 2 must be equal to 0. So we have 2 times minus 2 cubed plus a times minus 2. I would urge you to bracket. Your first line of any work should always be taking care with showing that you're actually understanding the first idea, which is the factor theorem, factor remainder theorem. Bracket it. I'm not using a calculator here, but it's obviously you can in C2, but you need to take care with signs here, because this is going to be a negative 8. It's going to be negative 8 here, but I'm timesing that by 2, so that's minus 16. This is going to be positive because I'm squaring it, so that's plus 4a. Minus 2b minus 6 equals to 0. So I get 4a minus 2b, and if I take the minus 6 and the minus 16 over to the other side, I get 22. Okay, so now I've got a simultaneous equation. Now, because sometimes I might have just broken this down, because I could have divided by 2, but that would have been a kind of backward step here, because I can see that this one's got plus 2, and this one's got minus 2, plus 2b, and this one's got minus 2b. So if I add the two equations, I get 5a equals 25. Oh, this is nice. The numbers are working out nice and easy. So a is 5. And then if I put 5 into either of the two equations, this one's a slightly smaller one, I get 5 plus 2b equals 3, which gives me 2b equals minus 2, which gives me b equals minus 1. And that is the answer. Nice, straightforward factor and remainder theorem question.